Planet Earth is a complex and ever-changing world. It is through chemical and observational analysis that we wish to explore these changes. The systems covered in this presentation play an important role. Each contributes to the total carbon flux on Earth. Each of these Earth systems interact with one another on both a temporal and geological timescale. It is important to understand the natural processes behind this flux, as well as any anthropogenic influence that mankind may have. Welcome to the world of marine, earth, and atmospheric sciences. The interacting systems of concern are the atmosphere, hydrosphere, geosphere, and biosphere. Each of these differ in capacity for carbon sequestration, retention, residency time, and ability to transport in and out of each system. Atmospheric carbon tends to take the form of carbon dioxide. This gas aids in trapping warmth from the sun in the atmosphere, keeping the planet warm enough to inhabit. The primary fluxes in the atmosphere are precipitation, diffusion, and fossil fuel emissions. The hydrosphere could very well be considered a natural sink for carbon. Carbon in this system has many uses to an abundance of organisms that sequester the carbon for the formation of calcitic and orogenitic shells. Ultimately, however, carbon within the hydrosphere acts as a double-edged sword, as the increase in dissolved CO2 can lead to the production of carbonic acid, producing a harsher environment and potentially degrading the very shells these organisms work so hard to produce. The primary fluxes are diffusion and the weathering of various siliciclastic and sedimentary rocks. The vast majority of carbon on Earth is located within the lithosphere, in the form of soils, carbonate rocks such as calcite and dolomite, as well as kerogens and fossil fuels. The carbon within the geosphere can remain within the system for millions of years, traveling deep inside the Earth, only to be extruded once again by volcanic activity in the form of igneous rocks or from the gases released during the eruption events. Carbon fluxes within the system can also come from weathering and resource extraction. Carbon within the biosphere plays an important role as it is the backbone of organic molecules, which in turn, under the proper conditions, form something not witnessed anywhere else in the solar system: life. From plants to the animals that feed on the membrane produced, carbon is in constant motion. The primary fluxes within the biosphere are photosynthesis, respiration, and decomposition. Possibly of most concern, or at least the most exposure of late, is the anthropogenic influence. From personal travel to power production, carbon emissions play an important role in the total flux observed. From the air, land, and sea, to the rocks beneath our feet, the dynamic shift in carbon chemistry among the various systems of Earth are part of what make up our unique world. Only from a better understanding of these individual systems and how they interact with one another will we perfect quantitative predictions with respect to the rate of flux in and out of each system.